Alrighty, everyone. So this is the beginning of chapter 6, lesson 1. We're going to revisit what inverse functions are. So let's get right to it. We're going to begin by reviewing what is an inverse. So an inverse function is a function where the original domain values now become the range values, and the range values become the domain values. So basically everything gets switched. So all the x values that that you would substitute into the original function are now going to be the y values, and the y values are going to be the x values. So everything gets swapped. All right, so that's what an inverse function is. It is used to find the opposite of what you actually have at this point. All right, so we're going to begin with a linear function right here. So example A is f of x is equal to 2/3 x minus 5. This is a linear function, and I'm going to find the inverse by, first of all, understand that f of x is the same thing as y. And then I am going to now begin the process of finding the inverse by making the y into an x and making the x into a y, so that I'm able to now solve for the new y. So I'm going to add 5 to both sides. So I'll have x plus 5 here equals to 2/3 y. And then I got to get rid of 2/3 by multiplying by the reciprocal, which is 3/2. So if I do that, I will have 3/2 being multiplied with the quantity x plus 5, and that would be the inverse. Now you can literally multiply 3/2 to both, like this, to both terms. So you could have it as 3/2 x plus 15/2, and that would be your inverse. So we would write then that the inverse of f of x is equal to 3/2 x plus 15/2. You can write it like that. Now, if you wanted to check to see if these, in fact, are inverses of each other, you could graph them both. One of the things that we learned in the first semester was that if you graphed one equation, and let's say the first equation looked like this, well then, and let me make it a little better. Let's say it looked something like, let's say something like that. Well, then the other function would be a reflection across the line y equals x. So you would see the other graph something like that. Okay, so they would be reflected across the line y equals x. All right, that's something from the last semester. Just a quick recap of that, though, and we'll practice that in a little bit. But basically, this right here would represent the inverse function of the original. Okay, so that takes care of one. That's linear. Now let's go ahead and go with the next one. Letter B. Find the inverse of g of x, which is right now x squared. And that is actually the main thing we're going to study today. G of x is the same thing as y. I do want to find the inverse, so I begin the process of finding the inverse by reversing the variables. I now leave the new y by itself, so I'm going to get rid of the square by using the opposite, which is the square root. Don't forget, it's plus and minus square root of that x. So you take the square root on both sides, and that gets rid of it. Now the square root of x is going to stay like that, so it looks like we would write g inverse of x is equal to plus or minus the square root of x. Now here's something I want to share, because I did share it the first time. It wasn't like one of the main ideas back then, because we were just studying the main thing about what inverse functions were. But now here's what I want to do. I want to go ahead and graph the original function. I'll graph the original function in blue, y equal, or g of x, or y equals x squared. Well, that's a parabola. So let me go ahead and graph it here. So we would start at 0, 0. Then if you recall, it's 1 up, 1 across, 1, 2, 3, 1 across, 1, 2, 3, 4, 5, 1 across. Then that repeats itself on the left side, 1 up, 1 across, 1, 2, 3, 1 across, 1, 2, 3, 4, 5, 1 across. This is the way you graph a basic parabola. Again, a lot of things that we covered the first semester are kicking in here. So this is going like this. Didn't hit those points perfectly, but you guys understand, right? Okay, so anyway, there's your parabola. And then the inverse, remember, was y equals, or g of x, g inverse of x is equal to plus or minus the square root of x. Okay, so the square root of x is going to start at 0, and then you're going to go 1 here, 1 here. It's basically going to do the same thing it did, but now you're going, you know how on the original parabola you're going 1 up, 1 across, 3 up, 1 across, 5 up, 1 across? Well, now you're going sideways. Everything's backwards now. It's still going to be 0, 0, and I'll go over the reason why. But you're going to go 1 here, 1 here. 1, 2, 3, 1. 1, 2, 3, 4, 5, 1. It's basically a sideways parabola. So you're going to go 1, 2, 3, and 1 here. 1, 2, 3, 4, 5, and 1 across here. And you get this. This is the positive square root function right there. That little check mark in reverse, that is a square root function. And the reason that is the case, guys, is because if you substitute a 0 in the x position, the square root of 0 is 0. That's the y value. Substitute a 1, the square root of 1 is 1. The square root of 2 is a decimal. The square root of 3 is a decimal. The square root of 4 is a decimal. 5 is a decimal. 6. You don't get it. I'm sorry, 4 is 2, right? The square root of 4 is 2, sorry. You don't get to the next. Basically, you're going to substitute perfect squares into the x value. So the square root of 9 is 3. So that's why if you go to the plotted point, 0, 0 is there, 1, 1 is there, 4, 2 is here, and 9, 3 is there. Okay, so that is why you get those points. But you can see that everything's backwards. So the way we used to go 1 up, 1 across, 1 up, 1 across, 3 up, 1 across, the odd number, now it's sideways. So you're going 1 across and then 1 up, 3 and then 1 up, 5 and then 1 up. So that you get that little check mark. Now, the negative values also, because you have the positive values, you'll have the negative values. So when you do the negative part, you're going to get the same thing. 1, 2, 3, 1 across, 1, 2, 3, 4, 5, 1 across. You get these. Basically, you get the negative values because remember it's plus and minus. So the positive gives you the top loop and the negative gives you the bottom loop, which is basically a reflection across the x-axis, okay? So you're getting the square root of x, which is that loop kind of figure, and then the negative square root of x is the reflection, so you see the bottom half come up. All right, so overall, though, you get this. But remember, if we go back to even further when we started talking about functions, this is not even a function because it violates the vertical line test. So therefore, we can't even call this a function. So the more proper way of saying it is that the inverse of g of x is the equation y equals plus and minus the square root of x. This is actually the inverse, which is not a function. Now, if you want to call it a function, you would have to limit some values and say that you're only going to take the positive square root, like the g inverse of x. We're only going to do the positive square root of x. But if we go to the original picture, again, and you do what I was talking about earlier, the reflection across the line, y equals x. If you do this diagonal line, y equals x, you can see that every point has been reflected. So that this point right here is reflected across over here. This point right here is reflected across this way. And that's one of the properties, and that's how you know that you in fact did this correctly. Every point on the blue has been reflected, so let me point to it with the mouse here, has been reflected, so it's the same distance here to here as it is from here to here, has been reflected across this line, and that's how you know for a fact that these are inverse functions, because this point will be reflected over here, this point will be reflected over there, and so forth. All right, and then the other 2 points in the middle, well, they're right on the line. So there you go. So a couple of things that I wanted to mention once again. The main idea is inverse functions are the values, the original domain and ranges have now been flipped. So the domain has become the range has become the domain. Graphically speaking, they're going to be reflected across the line y equals x. That's the diagonal line right here, the basic parent function line. All values are reflected across there when they're in fact inverses of each other. One more thing I want to mention about inverse functions, and that is that when you do their composites, when you do the composites of each, they will offset each other. And these are simple. For example, let me check this here. Since the original function was y equals x squared, and the new function, well, let's call that g of x, right? G of x. That was the original function. The new one, let's call it h. I know it's g inverse, but remember it wasn't really an inverse. So let's call it h of x is equal to plus or minus the square root of x here. If in fact, one more thing that you can do is if you do the composite function, if you do g composite h of x, or if you do h composite g of x, let me use the composite symbol, this one right here. If you do that, either one, it doesn't matter which one you do, but let's do this one because it'll be easier for me to demonstrate to you without causing so much confusion. If I do h composite, and let me see, h composite g of x, that means that I'm going to substitute the g of x into this h of x here. So if I substitute the x squared into the h function, which is plus or minus the square root of x here, the x now gets replaced with x squared. The square and the square root will cancel each other out. So all you have left is plus or minus x. Remember that when you have composite functions, if the x is the only thing left over, it proves to you that they in fact are inverses of each other. So when you do composite functions, the result is only x. Everything else gets canceled out. Now this one was an easier one, but we can practice with more in class, and of course maybe even with another one later in this lesson right here. Okay, so there's your basic recap of what inverse functions are. Again, we did do those in the first semester, so we're going to tap on your knowledge there. And then, let's see, let's practice some more. How about we get one like, what is the inverse? Let's make this C here. The inverse of f of x equals x squared plus 3. Let's find the inverse of that. So I'll begin by first doing this. F of x means y. We begin the process of actually finding the inverse by swapping the variables. Now you leave y by itself, so you move 3 to the other side. So you're going to get x minus 3, and then you get rid of the square using the square root. Plus and minus the square root of x minus 3. Now, once again, because you have a positive square root and a negative square root, you get something that is not a function. So this is simply an inverse equation. So the inverse of the original is plus and minus the square root of x minus 3. That is the inverse, which is not a function. All these, and again, another thing you can do is substitute these values on the calculator, and you'll get x and y values, such as, for example, if you put a 0, you'll get a 3 in this function. Well, in the new function, when you substitute a 3, you're going to get a 0 because everything is going to get reversed. Okay? So all the functions that were there originally are now going to, all the coordinates are going to get flipped. All right, let's do one more just to kind of get some practice here. So if I have g of x is equal to 3x squared minus 7, once again, g of x is the same thing as y. I now am going to begin the process of finding the inverse by swapping the variable. You're going to go plus 7 on both sides. X plus 7 is equal to 3y squared. I got to divide out that 3 next, so I'll divide it by 3 on both sides. So you'll have y squared is equal to x plus 7 over 3. And then finally you take the square root. So let me get some more room here. So it's going to be plus and minus the square root of x plus 7 over 3. And that's going to be my inverse equation right there. Plus and minus the square root of x plus 7 over 3. All right, we have different examples that we'll try in class, but overall, one of the main things that we just finished doing was quadratics. So what's actually chapter 6 is going to deal with is the inverse of a quadratic, which, as you can see, you start off with a quadratic. The inverse is a square root because the opposite of a square is a square root. So that's the inverse. Now let's apply it to some of the things that you just finished coming from geometry last year. In geometry, one of the formulas that you deal with is the formula area of a circle is equal to, area of a circle is equal to pi r squared. Area equals pi r squared, right? So if this is a formula that if you start with a radius of a circle, okay, if you know a radius of a circle like 5 inches or so forth, well, you can substitute the 5 inches here, and what you're going to get as you work this out is you're going to get the area. But what if you want to create a circle with a certain area? So let's say you want to find the radius of a circle with an area of, and I'm just going to make something up, we're going to round it up to, let's go with, let's just say 80 square centimeters. Okay. So what you're going to do here is you're going to substitute the 80 into the area position, and you're actually going to find the radius. Now you've done that before, but just want to share with you that this is basically, you're going to use the same strategies that you just used for inverse, because remember, typically the formula is you start with a radius, you substitute it, you work it out, and you get an area. Now you're getting the area first, and you're going to go backwards to find the radius that's needed. Now you're not going to swap variables in this case because the variable you're looking for is r. So don't, but it's in this section that we cover this because it's the same strategy. So you're going to leave r by itself. So we're going to divide everything by pi. So we divide both sides by pi, divide this side by pi and this side by pi. It cancels off, it offsets over here. So over here you'll have 80 divided by pi. And then you get rid of the square using the square root. So it's plus or minus the square root of 80 over pi. Now, this will be the, now you just type that into the calculator. Now remember the radius cannot be negative. So basically we're just going to get the principal root, which is the positive root. We don't have to worry about the negative because there's no such thing as a negative radius. So whatever the square root of 80 over pi is, that's going to be the, oops, hold on, get a calculator here. The square root of, control divide, 80, if you wanted a circle with an area of 80 square centimeters, then you would need to have a radius that's approximately 5 centimeters long. Okay, so that's how that's going to work. And the thing that I like about this is that you can actually create an equation out of this. So if you go control radical, control divide, and then x divided by pi, you can actually come up, you know, you can input the, oh, there it is again. You can actually input the, you can now say, all right, enter here, control T, and you can find out, okay, if you have an area of 1, then you need this radius. If you have an area of, what was it, of 20, then you need this radius, and so forth. So you can find out exactly, you can go backwards and say, well, what if I want an area of 90? Because of 80 would be 5. Look, there's your 5, right? If you wanted an area of 125 or so forth, well, then you need a radius of 6.3 units and so forth. So you can actually use that's really why we use inverse functions, is to be able to calculate it at different variables. Okay, the last thing is going to be this right here. The function d is equal to 4.9 t squared represents the distance d in meters that an object falls in t seconds due to the Earth's gravity. Find the inverse of this function, and then how long in seconds does it take for the cliff diver over here on this right side to reach the water below. The water would be at 0, okay, ground level. So we are going to start this. Since they want the inverse function, you basically want the opposite formula, okay? we're not going to flip letters because distance is distance and time is time. So when you're given formulas, just like on the other one I just gave you, you're not going to flip letters, but basically right now the equation is being solved for D. I want you to rewrite the equation so that it's solved for T, so that would be the inverse in a given formula. All right, so I have to leave T by itself, so I'm going to divide by 4.9 on both sides. And then I'm going to get rid of the square by using the square root, plus and minus the square root of D over 4.9. Once again, time cannot be negative, therefore we're only going to be concerned with the positive square root. So the inverse function would be T is equal to D over T is equal to the square root of D over 4.9. And that right there, that's the formula that you can find to solve for the exact time it takes for something to drop from a certain distance down to the ground level 0. So over here in this case, it's 24 meters long, so you can actually type in 24 right there and then get that answer. Type it in, the square root of 24 divided by 4.9. Let's go back to a regular calculator right here. The square root of, control divide, oops. What was it again? 24 divided by 4.9. So 24 divided by 4.9, and looks like it takes about 2.213 seconds. 2.213 seconds. That's how long it takes. 2.213 seconds for the diver to hit the water. Okay, guys, well, we will do more examples in class, but hopefully you got this. Okay, bye-bye.